Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
I'm going to go ahead and open the file that you emailed us for the demonstration. Now, was this part designed and built in Rhino?
Yes.
Okay, great. So looks like you have a cabinet, is that right?
Well, it's basically kind of like a nurse's station or reception desk wall.
Okay.
That's got, this is what we do a lot of. We do a lot of commercial cabinetry also. But basically this would be the top plates and the bottom plates and the studs for the wall, the back panel, the front panels, and then all those removable panels. Well,
Okay,
reveal panels is what we call them.
So basically, they're all panels. They're all prismatic parts, or I would say flat parts. So we just
Yes.
have to break them apart and lay them out on a sheet and then process toolpaths on it. Is that right?
Correct.
Okay, great. So the first step we're going to do is once you have this part model, designed, and imported, opened in Rhino, you want to make sure that your RhinoCam plugin is loaded. So you'll notice that the RhinoCam's interface appears directly in Rhino once it's installed. You have the RhinoCam's machining browser over here on the left half, and then underneath it is the machining objects browser, which gives you access to tools, machining regions, machining features, and knowledge bases as well. Now, on the machining browser, you have two main tabs, Program and Simulate. Now, these tabs allows you to basically define your machine, create your workpiece, and then process and program all your toolpaths. Now, if these machining browsers aren't visible in here, you just click the RhinoCam menu and then you pick Mill, and that would display the machining browser. Now, we have a tool that's built into RhinoCam, which allows you to take cabinets or, like any set of panels that are basically built in, and we can basically flatten them out, or meaning we can basically put them on the XY plane, so it's easy for you to machine it. So you don't have to individually select and grab them and orient it to the XY plane. So what you could do is you can go over to the machining browser and the mill module, and then click under CAM Utilities, and we have this feature called Explode Cabinet Design.
Okay.
So you would select Explode Cabinet Design, and this brings up the dialog where you can establish these parameters. So in this particular step, I'm going to choose to explode all geometries or all the parts that are visible on my graphic screen. Or you could choose explode selected, or you can only do explode by layers. In this particular case, I want to do explode all visible. I'll pick that, and then I can choose how to place these components. I could place them along a single row, along X, or I could place them along Y, or I can array them along X first and then stack them up in Y, or I can do an array, a fixed distance along Y. So if you're going to be using a router, your sheets probably are going to be either 4x8 or standard sizes, right? So if you want to make sure that the Y on the router is going to be 8 foot, which is 96 inches, I can put in a fixed distance, and then I can set also spacing between each panel when I explode them. And then once you set these parameters, you have the option either to export them both as 3D geometries as well as two-dimensional curves, or if you just want to output them as two-dimensional curves or just 3D geometries, you have options to specify how you want it to be, these objects to be exported. And also you can specify them either to leave them on a parent layer, or you can place them onto a new layer if you'd like to put them on a new layer. And you can hide the original geometries once you explode them or decompose them. And you can place all the curves that you're extracting into one plane, so it puts it on the XY plane or makes it planar. Right. So would you like me to place them on a new layer, all the geometries what I create, or would you want me to leave them on the current layer?
Probably I would prefer, if I was doing it, I would put it onto the 0 default layer.
Okay. All right. So I can choose a new layer, and it'll automatically place all of them on a layer, a new layer,
That's
or
fine.
delete.
Okay.
Okay.
Yeah.
So now when I
That would be
pick
ideal.
OK here, you'll notice that it's going to process these panels, and they're basically placed onto the XY plane. So if I hit Fit View and go to the top view here, you'll notice that it automatically decomposed all these panels, meaning it laid them out flat.
Mm-hmm.
As you notice, since the new layer I chose was automatically assigned a layer color,
Sure.
see that it shows up in the layer tree. So you could go back in here and change the color of the layer if you wish, and they'll all be on a new layer. You can see that they're automatically placed right here. And I just chose 3/4 of an inch in here. If we're going to be using a 1/2 inch cutter, that room should be enough, right? So all it did was it basically took all of these, the assembled, the cabinet, and then it basically flattened them out on the Z0 plane, as you see it, right?
Okay.
Now when we do a select all in here, you'll see that there's so many curves, extrusions, and poly surfaces. Now, are you looking to nest these into a sheet before programming toolpaths, milling them, routing them? Okay. So what I could do is I can select these curves and invert the selections, and you'll notice that I just deleted those solid panels in here because all I need is curves or just 2D geometries for nesting. So when I chose to do the explode cabinet design, I could have just chose the option to pick only these curves in here, as you notice it.
Right.
Okay. Now I'm going to select these, and I'll just basically stage them below the origin in here. And what I'm going to do next is define my sheet to be able to nest these parts. So I'm going to click on Create a Rectangle in Rhinoceros, and for the sheet, I'm going to specify they're going to be 48 by 96. So is 96 along the Y-axis for your router?
It's actually the other way.
The other way? Okay, so it's 96.
Yeah.
So the X is going to be 96?
Yes.
Okay. All right, so we defined a sheet that's 96 by 48. Now, we would like to nest these parts into the sheet. So we would want to go into the nesting module. So you go to RhinoCam and then pick Nest. We have true shape and rectangular nesting options available.
Okay.
Now, typically for cabinet work, panel work, you would want to do a rectangular nest.
We use true shape nesting just to be able to be able to fit more parts and occasionally be able to get more parts because you can fit parts
choose
inside
the orientation. Yep.
Yeah.
Makes sense. So I'm going to pick true shape as you recommended. We'll pick the sheet, and I'm going to click on Select Curves, grab this rectangle as my sheet. So the sheet is now defined. And I'm going to choose Select Parts to Nest, and I can choose Select Curves, and I can drag a window to select these curves, right-click to accept it. So you'll now notice that there's a total of 53 parts that are displayed in here.
Okay.
And you can specify your orientation step angle. You can choose the mirror parts. If you have parts inside of the parts, like you have like holes, you can have allow parts inside of parts. In this particular part, there aren't any holes in here, so I'm not going to make the selections in here. Now for the nesting parameters, you can set the distance between each part, the minimum distance you would like to maintain between each part. So this would depend based on what size cutter you're planning on using.
Right.
Right? So
we generally do 0.4.
Okay, so we'll put in distance between part to part as 0.4, and then distance from the part to the edge of the sheet. This could be
We
same
generally
as
do an eighth of an inch.
Okay,
Yeah.
put in an eighth of an inch, and you could choose to tag these nested parts if it's an option, or you could choose to basically choose an annotation or geometry, and then also you can specify how would you like the sheets to be laid out. Do you want them to be laid out stacked on top of each other, or you can have them side by side? So if you like to have it stacked on top, you can just choose stack right in here. And if you pick estimate number of sheets, this will let us know how many sheets would be required to be able to fit these parts in the cabinet.
Okay.
right? So it says it requires 8 sheets. I'm going to hit update sheet count. It automatically updates the sheet. And now I'm going to do execute nest. So it's processing the nest and then hit preview. So you'll now notice that there's total of 8 sheets. Sheets 1 of 1. You can see that they're basically processed into it right in here. And I have an option to create a separate layer for each sheet or separate group for each sheet. So I'm going to use separate layer. So each sheet will be output as a separate layer.
Okay.
And I hit export. Okay, so if I choose export, it'll export it as separate files, but I want to just export it commit it right in here. So I just choose commit nest. So you'll now notice that these sheets have been created right in here.
Okay.
You got all the different sheets. And if you notice here, I can toggle the layers of the sheets, and there's all our sheets. The first sheet, second sheet,
Sure.
sheet 3, sheet 4, 5, 6, 7, and 8. Right? So now we're ready to program toolpath on it. So we switch back to the mill module. And let's look at programming the sheet. So here we wanted to go ahead and profile cut these out, right?
Yes.
Okay. So here's how I'm going to program it. So I'm going to first define my machining process for 2 and 3 axis. We would set it to 3 axis. Then the next step is to select the post processor. This would be the machine tool or machine controller you're working with. And we currently have posts for over 225 plus different machines and controllers included, so which covers a wide range of machine tools that are out there.
Yeah, we use the Osaya inch right now.
Okay, so we'll go down on the list and we'll make sure we select OSI from the list. And we have posts for inch and metric outputs, optic inch. And we could choose the output extension to be NC or whatever is the preferred extension.
It's NC, yes.
Now the next step I would like to do here is process these toolpaths in here. So I want to define some tools and then program toolpaths. Now before I do that, I want to make sure my orientation looks correct, and you can see that the origin is over on the southwest corner. So we'll go ahead and build our workpiece. Create a stock. And are these going to be 3/4 inch panels?
Yes.
Okay, so we'll put in a height as 0.75. I can also just pick the top of the panel to be on the 0, so it's flush to the edge of the stock sheet. So you'll notice that the stock is going to be 4x8, and the 0 is set right up to the top. So your stock is defined. The next step is to select the operation. So we would want to profile cut these. 2-axis profiling. You select the features for profiling. Click on select curve edge regions. And I could just drag a window to select all of these geometries. The next step after you make your selection for the part regions, you make a selection for the tool. You can click on your tool, create edit tool, then you can pick the type of tool. We have ball mills, flat mills, corner radius, tools for engraving, chamfer, taper. You could use face mills, dovetail cutters, fillet mills, lollipop cutters, and form tools on a profiling operation. So in this particular step, you would specify the cutter properties. So is this going to be a 3/8 or a 1/4 inch mill?
Yeah, 3/8.
Okay, we'll put in 3/8. We'll specify, call it flat 3/8. And you can establish all the properties in here, set your tool number, your material, go over to feeds and speeds, choose load from file, and you can choose the type of material you're working with, and you can update this list to have different varieties of wood added in here. You can set the surface speed, the feet per tooth is the property of the cutter, and the system can give you recommendations on the feeds and speeds. So if I lower my spindle speed, you'll notice that the cut rate changed. I can also override the cut rate. I can say I want to go only at 75 inches per minute. And this information gets updated in here. I save this up as a new tool, and I can save the tool out to a library. So the next part I'm going to be cutting, it will be from the library. The next step is to go to your feeds and speeds. You can see load from tool. It's loading it from the tool. You have your clearance which is the safety plane for all the transfer motions. It's defined to be automatic, which means it'll automatically clear the maximum height of the stock or the part, whichever is higher. In this case, it's going to be a 1/4 inch above. In the cut parameters, you could choose whether you want to cut outside or inside. You can choose your cut direction. So all these settings controls are offered in the cut parameters. And also I've chosen this option called use midpoint of the longest edge. This will ensure that the cutter will not enter in one of the endpoints where the start point of the actual geometry is. It'll establish the midpoint of the longest edge. So in this case, it's the longest. We'll pick that automatically. And this is especially very useful for cabinet work, woodworking applications where you want to ramp in along the midpoint of the longest edge. And then you go down to cut levels here. You specify the total depth. So if you want to go, 3/8, 3/4, or whatever the depth is, you can just type in here. If you want to put in 3/4, I can just type in the depth.
Okay.
And it will compute the total depth in here. If you want to go slightly into your spoil board, you can add a thousandths or something like that.
Right.
You can specify those parameters, and then right in here you specify your entry and exit. Now, going back to cut levels, if you want to split this up into more than one level, you can say you want to go 3/16 per cut. You can break it up into multiple pieces.
Sure.
Or if you want to leave like an onion skin and go back and do a written onion skin, you can specify to go only 700 thousandths deep on the first cut, and then you can go back and do another cut to clear it out. If it's vacuum held, then you should be fine.
Okay.
Entry and exit, you can do lines and arcs. You can ramp in. If you choose to do lines and arcs, you can specify, in this case, I can do a linear. I could specify the parameters in here for, you could say, go like a 50 thousandths linear entry. I can give it an angle in here, maybe a 2 degree, and then a height for it. I could say 0.75, the same as the total height. And I could do the same step for the exit as well. So basically use a linear with these parameters in here. And I can apply entry and exit. If you're doing multiple levels, you can do it for each level. You can also have an overlap distance in here. So that way you go past the entry point before you leave it. I could say put a half an inch overlap distance. And you can set any additional parameters like arc fitting. You can also do sorting in here and pick generate. So in this process, it's going to process your tool path, and you can see here it's ramping along this curve path as you notice it. It's not just plunging it, it's ramping. And I could change the angle in here, or right in here, I could specify it to be like a 10 degree. It's going to ramp along a 10 degree path as you notice it.
Okay.
And it's ramping in here at, the height is set to 3/4. I can lower it down to maybe just, 0.15. So it's going to use much of a gradual ramp as you notice it.
Right. Okay.
And once you have the tool paths programmed, you would then go into the Simulate tab, select the operation, click on Play, and that'll give you the cut material simulation or verification. You can also speed up the simulation.
Okay.
Cut all the way through as you notice it. If you'd like to add bridges and tabs, we do have options to specify bridges and tabs right in here. We could do triangular bridges, or we could even do rectangular bridges.
Yeah, we generally just, if it's a smaller part, we'll just completely onion skin it and leave it onion skinned. Is what we've had the best luck with.
Okay. So in here we process the first part, right? So this is part number 1. Now if you'd like to process each sheet in a separate file, you can export them in Rhino and then program it. Or you could program all of them in one. You could call this profile for sheet 1, or you could even organize it in a better way by putting into a machining operations set, and I can call this sheet 1. And I can stack this into the sheet, right? Into the sheet 1 folder. I'm going to make a copy of this, make a copy and a paste. And I'm going to hide this layer and make this layer visible. All I do is double click on this operation, remove my current selections, make this as my new selection, generate it. So I can rename that to be sheet number 2.
Okay.
So I can rename this as sheet 2. So repeat the same step, copy and paste it. Switch to layer visibilities. Swap this to sheet 3. Select these geometries in here. Generate. And the toolpaths are generated. You can see that there's enough room between these, so that there's enough room for them. So they're not overlapping. The toolpaths aren't overlapping, so you're not going to end up having the parts being smaller.
Got wrong. Right.
And since we've specified a sorting, it'll minimize the amount of transfers from one part to the other part within the sheet.
Good deal.
So I want to show you one other powerful feature. In this process, we are actually selecting the parts, right? We are going through the process of making selection for each of these parts in here. Now, rather than having to go through the process of selecting each of these parts, we could automate that process as well in a knowledge base in here. So what I'm going to do here is save these to a knowledge base. And what I'm going to choose to put it is I'll put it in this folder called data. Okay. Now I'm going to go down to the machining objects browser, and I will go ahead and go to this tab called KBases, knowledge bases, and I will click on load knowledge base, and I'm going to load this knowledge base in here. And I'm going to be prompted with this dialog, would you like to specify rules? Since I want to specify rules for just one of the operations, I'm going to choose no, so it'll only set it on one of them. And let's say we only want to consider one of the sheet in here, right?
Sure.
So I'm going to expand this profile operation. I'm going to click on select rules, and I'm going to apply what is called a color filter in here and use the pick option to pick this color. So I wanted to profile cut the exterior based on a certain color that's assigned to the geometry. I'll apply this in here. Okay? Now, if I go back in here and save this to a knowledge base, I'm going to call this knowledge base with rule. So I'll go back in here, I'll reorder this. So the rules are, it's saved with the rules in here as you notice it, right? It's assigned the rule to it. Now if we go up to the machining browser, I could choose to load my knowledge base. I'm going to load the one with the rule on it. You'll notice that this has the rule set up to it, right, as you see it? This particular setup in here, we will establish, save it to a knowledge base, and we'll go back in here to assign the rule for it. So we want to make sure the rule is set, so we are specifying it to pick objects of a certain color. So we'll go back and update this with the rules to the knowledge base. Now, if I go ahead and, rather than having to select it, if I load my knowledge base, the one with has the rules on it, you'll notice that it automatically has those geometries selected.
Okay.
So I don't really have to go and pick individual geometries. Now here's the beauty of it. Now let's say this particular layer, I'm going to say select objects. And I'll export this to a file. I'm going to call it sheet 4, right?
Okay.
I'll go ahead and open up sheet 4 in here. So I have sheet 4 pulled up. I'll define the stock for it. And all I'm doing here is loading my knowledge base with the rules. And this automatically has a geometry selected. Right click and generate. So you can automate your entire workflow. You can have multiple operations and you can assign rules. The rules can be set to select based on layer, geometry type, or color. We could use different options.
Okay.
So if you like to have each sheet programmed in a separate file, this is how you do it. And then you right-click and do a post, and you have sheet 4 setup 1, post-process it, and your G code is output right in here, ready to be transferred out to the machine.
Good deal.
There be any questions, Matthew?
I don't think so. That cleared up a lot of crazy nonsense that I was having trying. Explained a lot.
Okay. So what we did basically, just to summarize here, was we loaded the file. We used the explode cabinet design feature from the mill module to basically flatten them out, and we could output them as just as curves or solids plus curves. So since we would like to nest them, so exporting as curves would definitely be very useful, right? So, and then once you export them as curves, you could then go ahead and establish the nesting process by going to the nesting module to nest them into a sheet. And once you have them nested, you can either export the nest to separate files, or you can export them all into the same file and then process your toolpaths. Now, if you'd like to export them into separate files, here's how you do it. Let me go ahead and save this file, and we'll go ahead and export them to separate files in here. So I'm going to go back and reload this part, and I'll hide all of these geometries. And if I do a show, it'll actually show the entire cabinet that you have, right?
Yeah.
Okay, that was the cabinet. I'm going to hide it again, and we'll look at the initial result after the exploding of the cabinets in here. Now we go over to the nesting module. You select the sheet. You select your parts. You establish the nesting parameters. And we would set it to stack. We would estimate the total number of sheets needed. So that way we can update the quantity of sheets.
I have a quick question.
Sure.
If you do it instead of stack, if you do it along X or along Y, does it automatically know that for each one of those sheets where 0, 0 for the actual sheet is?
That's a very good question what you asked. So there's an option when we export it, we can move it over to the origin. So if you choose along X and you specify a spacing between each sheet, let's say keep it at least 2 inches, I would do execute nest. And I would preview the nest, so you'll notice that they're basically previewed side by side over here.
Right.
And right in here, you have create a layer, separate layer for each nested sheet, and then it says move every sheet's lower corner to the origin.
Okay.
Now I'm going to choose an export path in here. I'm going to put a folder on my desktop. I could choose where I would like to place it. I could say add a new folder in here. And I'm going to pick that folder. And I have this option selected. I'm going to pick export. So you see that you got a confirmation saying successfully exported.
Okay.
So all of these have been successfully exported in here. Now what I'm going to do is each part, each sheet is going to be exported as a separate Rhino file. Now I'm going to go back in to Rhino, go to the folder where I had it. On the desktop I should have a new folder, and you'll notice that all of those 7 sheets are right in.
And then every one of those will just be moved to the origin.
As you notice here, you're right. The first one is at the origin. Let's look at the sheet number 2. It is moved to the origin.
Okay.
And we can, let's pick a random sheet in here, number 5. You'll notice that they're all at the origin. Now here's the power of the knowledge base with the rules we set up in here. So we loaded one of these sheets. loading the mill module. I'm going to go load my knowledge base and pick the knowledge base with the rules established on it, and right-click and generate. My toolpaths are generated, so you see the automation built in here.
Sure.
So I didn't have to go through the process of making any selections for geometries. And I'm just defining my stock material, and I can run the verification, the cut material simulation.
Now, does the stock material, is it something that stays the same as what was previous chosen?
In the session, it would remain the same. One of the things you could also do here is just define a part box stock and give it a height. And you could just do a part box stock, or you can have a solid model in here or extrusion to define the stock. Stock is primarily used for running a verification or for the purpose of simulation. So by just exporting the nest result, it's not going to save the stock information on it. It's just going to save geometry information. So you would either have to create a stock to be run through verification or simulation, but it's not necessary if you just wanted to quickly program it and then post it out to generate the G-code output. So you can see sheet 5 profiling is ready to be sent to the machine.
Okay.
So we can keep loading parts in here and process the toolpaths by loading it from the knowledge base. And since we established the rules for the knowledge base, I load the knowledge base with the rules, generate the toolpath. So no selection of geometries in here. I would say just a 3-button click: load the file, load the knowledge base, right-click and generate, and then the last option would be to do a post-process write-up code. So your operator in the shop floor can be getting the parts ready to cut and have all the programs programmed within, I would say, less amount of time, so more productivity.
Right. Absolutely. Yeah. Yeah. Right now it's just I do all this, and then I'm trying to convince the company to pay for the RhinoCam, because currently we have AlphaCam because it works really well with cabinet vision, and that's what we generally make most of our just traditional cabinets. It works really well for that. But any parts like this, I always have to draw in Rhino, which I usually just draw in block form just to get a picture to the client. Then I have to turn it into parts, and then I have to turn it into curves, and then I have to export it to AlphaCam, and then I have to nest it. It's just I finally got sick of and I've just finally gotten sick of that and figured this would be a much better way. And now I think the good thing is I think my company is realizing the amount of time that they can save in my work, which is going to save them money. So
absolutely, time savings results in savings in costs.
Yes, I like it.
Now, would there be any questions on the workflow or what I demoed to you today?
I don't think so.
Okay, so for this, what we demoed today, you would be needing the mill module, standard configuration, which is recommended, ideal, and the nest module to be able to nest those 2D shapes into a sheet.
Okay.
So you'll be looking at the RhinoCam mill and then the nest module.
Okay.
So what I'm going to do here is put you in contact with my manager, who will be able to follow up with you on the demo and also provide you the information that you need for these modules. And also, if you need a copy of Rhino, you can also find out how you can get a copy of Rhino as well.
Yeah, well, I have that. That's good.
Okay, perfect. So just give me one moment while I transfer the call.
All right, thank you very much.
You're welcome.